A warm good evening to everyone. I Lalit Kumar Sahu personally, and on behalf of organizing committee TENSYSMP 2022, would like to welcome Professor Ashok Jhunjhunwala and all the delegates to this evening talk. It is my privilege to introduce Professor Ashok Jhunjhunwala. Professor Ashok Jhunjhunwala is a professor at Indian Institute of Technology, Madras, India. Following his BTech degree from IIT Kanpur, he obtained his MS and PhD from University of Maine, USA. He has recently completed 1.5 years of his service as Principal Advisor to Ministry of Power, MNRE and Railway, Government of India. Professor Jhunjhunwala has made numerous technology contributions which impacted the lives of many people over 25 years. Professor Jhunjhunwala is considered as pioneer in nurturing industry-academic interaction in India towards research and development, innovation and product development. He conceived and built India's first university-affiliated business park, IIT Madras Research Park. He has been developing product for masses, affordable yet technically advanced in India. So, I welcome Professor Jhunjhunwala. Thank you so much, sir. I would like to request Professor Satyanarayana sir to welcome Professor Ashok Jhunjhunwala with bouquet. Welcome, sir. Welcome to TENSYSMP 2022. Thank you so much.
Thank you very much. Is this also on?
Yes, sir.
Yes. Good to see you. It's Saturday evening. I have told you there's a dinner, so hopefully you'll be staying for dinner. So staying before that is okay. But I'm told there's also one more session before that. When you pull things here and there from where a lot of information is not right. By the way, I'm at IIT Madras. I have worked only with the government for only about 18 to 20 months. I'm not with the government. So I'm not working with the government for the last 5.5 years. I am very much at IIT Madras. We built IIT Madras Research Park. I think it will show up here. And I will request if you have not visited IIT Madras Research Park, I request each one of you to visit. If you want, you can take my email ID. My email ID is not there. Sorry about that. I'll give you my email ID and do write to us and visit us. What I'm going to talk today is something different. Professor Satyanarayana told me that maybe I should talk about entrepreneurship and industry, academia, interaction, and all that. I could have, because that's one of our major work. But I thought I will talk about something which is extremely critical for India, and where we'll have to make a difference and we will make a difference. So I'm going to talk about I prefer myself just take it out. Yeah. The microphone is going inside there. So, now things sorry about this. So what I'm going to talk about, how soon can India get to net zero? Even the importance of why India should get to net zero at the earliest will become clear. And I also said that can we do it by 2047. You may remember that our Prime Minister has announced a target of 2070. It's up to us, the researchers, R&D people, and electrical engineers always will play the significant, dominant role in all this. So I'm going to talk about why it is important and how can we go about doing it. And I'm not talking for a talk's sake. We are determined to do that. And I'm trying to put together all researchers and hopefully all of you to get the world, India, to become net zero by 2047. Before I delve into more detail, let me get a few simple things that we often do not understand. All of us have been hearing about, who is this? The greenhouse gas emission, the global warming. What is often not understood? Who has contributed to this greenhouse gas emissions, or who contributes today, and who suffers? I think these pictures are very, very important. So this data is very, very important. The first data that I want to point out is, see that actually it is a top 10% contributes to 49%. The next 10% contributes to 19%. The bottom 50% hardly contributes to about 70%. But this is still misleading. Emissions dominated by well-to-do in every country, including India. I think this is something that we must understand. But even more important is this next figure. See, this was the total. Now look at per capita. Per person contribution to the next year. And you see, top 1% contributes to almost 50%. Per capita, top 1% of people, and this is anywhere in the world. Anywhere you take top 1%, they are contributing to the 15% of the GHG emission, and the next 9% contributes to another 10-12%. Bottom 50%, you can't even figure out how much they contribute. And most of India is in that bottom 50%, remember that, in terms of income. Contributes to practically negligible. Well, now these are all public figures. There are references I didn't put here, and I can send you this presentation if you want. So this is something that we must understand. I'll go one step further. But who is impacted? Who is impacted? The ones with the lowest income gets impacted first. Everybody is impacted, but the ones who have the lowest income gets impacted to a maximum extent. And that's where India comes in. By and large, I don't know how many of you know that 85% of India's population per capita income is less than 6,000 rupees per month. 85%, which means a family income is less than 25,000 rupees. That is 85% of India's population. So that is where, and that's today true. Even though it has improved quite a bit, our GDP has grown up, per capita income has grown, everything has grown, but still 85% of the population still have less than 6,000 rupees per month income, which means in a family of four, approximately 25,000. So these are the households, 85% of the households. And this is where things are going to get very, very bad. And it is not in remote rural areas. I show here a picture of Chennai. Last December, there was a rains in Chennai for 7 continuous days. Nothing very unusual, pretty much like a little more heavier than the normal years. I think we still have not got affected badly by what the GHG emissions will do. But even with that, even the well-to-do people in my research park, there were at least 100 people living in high-rise buildings, earning more than 1.5 lakhs rupees per month, who are coming for 1 week by boat. That's the only way to come. 1 week they came by boat. They'll come to the main road by boat from their homes. Now, if they were affected by this, imagine what would happen to the low-income living. These people are living in a household, in a high-rise. There are 20-floor complexes and things like that. And this is, so invariably, the GHG emission, the climate change is going to impact the poor very, very badly. Even though India may not have contributed maximum, the top 1%, top 10% have contributed quite a bit. This is something that you must understand. We are the one who will suffer. So what does one do? Let me take another picture. And I remember talking to Prime Minister about this in 2016-17, first time when I started understanding that. And this figure was more or less the same figure, it slightly changed. In terms of per capita GHG emission, India is very, very low. We are led by the United States, Canada, South Korea, etc., etc., etc. India comes way below. It is 103rd in terms of per capita emission. So, in fact, when people saw this picture, he sort of said, well, then why should India be so focused? And it took me quite some effort to go back to him with more data that India has to be very concerned because we are the ones who are going to get affected. And let me go one step further. So per capita wise, if you see, it is the same. It is this in Singapore, and with if I plot per capita consumption based on carbon dioxide emissions versus the income, and all these countries, United States, Singapore, Canada, all these countries come, and India comes way here. India, Pakistan, with only it is slightly better than Tanzania, Ethiopia, and all that. So, in some sense, one can say, why should India be the main focus? And yet, I will show you in this talk that why should India be the main focus. Forget about per capita. Take the total emissions. Total emissions. Remember, we have a large population. So the per capita has to be multiplied by 1.37 billion. Once you multiply that, you see that India is only a third. Of course, the highest is China, the United States, and there is India. It doesn't stop here. If you look further, GHG emission increased by 335% since 1990. So we have gone up 3.5 times. And we are going on at the same speed. As our population is growing, as our GDP grows. Now, GDP growing is very, very important because we have lots of low-income people. But as GHG increases, our energy demands increase. And as our energy demand increases, the emissions rise. So it's a matter of time, probably 10 years, where we will cross the United States. And will be India and China should have primary contribution. So even in terms of contribution, we are very, very significant. In terms of impact, we will be amongst the best. So all this is something that we very often don't understand, and I thought I would present that. India needs to act now. And see this. This is what's happening in India. If you look at it, we were fairly low in terms of consumption. Air conditioner, for example, very low till then. And now suddenly starting to go. And it's projected by 2040, we'll have 1.6 units of air conditioner per household. Today we have hardly 0.2, 1 in 5 households has it. But the air conditioner demands, as the income grows, that's going to happen. Air conditioner, refrigerator, television, all this is going to grow. As the income grows, the income is growing. I don't think anybody is sitting out here will live without all this. So soon we are going to start hitting and becoming a dominant GHG emitter unless we take action. And we'll talk about what action can be taken. So India must get to net zero while growing its GDP. Now this is a very important. One thing is that stop growing the GDP, but that's not an option for us because 85% of population is still very, very poor. So we have to grow, and yet we have to control our GHG emission. And this is where this conference comes to become very important. Is a research, development, innovation can get us there by 2027. And I'm not going to do empty talk. First, I'm going to present details and then actually pursue this to the extent that I can. It will cause huge disruption. Let me tell you. And we'll talk about disruption also. What should be the strategy? Well, India's top 10% away, which, if you look at the income bracket, top 10% away. In fact, I will even say us professors who were not considered rich in any manner till 10, 15 years back, today we have significant surplus income. And most of you, if you are not graduated, within a few years of your graduation, you will get a lakh rupees, a lakh 20,000, or something like that. But once you start doing that, this is a surplus income. Your consumption is not going to be that large. So you are required place to save. And where will you save? All of us have to save money. And we are very willing to invest at places where there is a return on investment. So what should be the strategy? The strategy that when to look at invest is commercially viable. What is a commercially viable? Return on investment. I'll define that. If our students do not understand this concept of return on investment, there is a problem, and you need to learn that. And some policy intervention and incentives to make. I'll also define this is the role that industry and academia has to play. The role of government, on the other hand, should focus how to manage change, preserve and grow employment and GDP. Remember that the government is not going to do R&D. In fact, the worst thing that government can do is that start saying this R&D you do, this R&D you don't do. Who sitting in Delhi can figure out what should be done, what should not be done. It can only be industry and academia. So, role of government, and I'll elaborate upon that, preserve and grow employment and GDP and manage change, not really intervene on technology, not start making technology choices. And I'll get into details of that. So let's look at another aspect. First thing is, renewables in India is growing very rapidly. I think all of us know. Today, solar and wind-based electricity costs between 2 rupees to 2 rupees 50 paise in large quantity. And this number has been going down. Just see, it used to be huge in 2010. It used to be 14, 15 rupees. Now it is 2 rupees to 2 rupees 15 paise per kilowatt hour per unit of electricity, which is by far the lowest. Even coal cannot produce at 2 rupees 50 paise or 2 rupees per kilowatt. So solar and wind has gone down. Lot of R&D has gone on and made that possible. We'll talk a little more about it as we go on. So, coal-based electricity, on the other hand, costs more. Particularly the new plant. If the old plants are there, they are depreciated, you only take marginal value, it's all right, 2 rupees 50 paise. But the new plants will cost 4 rupees because you have to put all pollution control equipment, etc., all that. And oil and gas-based electricity cost, and we use diesel generator all the time. It is between 28 to 24 rupees per unit, and this is not the latest figure. This was, I think, number I revised when petrol price had gone to 70 rupees. Now it has gone to 100 rupees. So that will become worse. So if you look at it, from this will say it's obvious now we should move to solar and wind. And we move to solar and wind, we'll move towards net zero. No? What is the problem? What stops India? The first question that is asked, which was asked me in Delhi when I took up in 2016, I was driving this program, is India has enough capacity. Can we put enough solar and enough wind? We actually calculated that even you take desert and you take something like 5% of Rajasthan desert. If you cover that with solar, you can supply all the energy needs of India for the next 10 to 15 years. So there is really no dirt. There is enough land, enough wasteland, and in fact you can put it and you can work under also, and there is enough land to make as much solar as possible. Wind also there is a plenty of capacity. And now another new thing that has started to happen is, and there we have to play a major role, the wind-based power plant off coast. I mean, going on a kilometer or 2 kilometers down in the ocean and setting up the wind plant. That currently is very expensive, but India has a capability of taking it up and making it a very low cost. So wind and solar we can really grow, and we can go to 500 plus gigawatt of wind and solar by 2030. That, by the way, the Indian government has. So we can get there. And there is some R&D that needs to be done on this. Will come to that. Installed capacity of renewable energy is already 27%. So this is the installed capacity. Anyone wants this slides, they should write an email to me and I will send that. Installed capacity is 27%. And coal is 52%. But the total electricity generated is small, is only 12%. The reason the total electricity generated is only 12% are from renewables. So it's only 12%. Most of it is coal, only 73%. Even though coal in terms of installed capacity is only 52%. Why? Because coal can give you electricity 24/7. Solar cannot give you 24/7. Solar will give you electricity only in the daytime. Wind will give you electricity when wind is good. So these are not 24/7, whereas coal it can be 24/7. So that different. So just having, we keep on talking that we have 27%. 27% has no meaning. Actually, solar and wind we have only 9%. 3% is added because of some other things like biomass and all that. So actually, it's only 9%. However, solar and wind based electricity is not available 24/7, and therefore very, very important area that we really need to make this happen is how do you make energy storage. And energy storage is a very, very hot area that we need to really do. Today, energy storage is extremely expensive. Of course, batteries, we know of batteries, but extremely expensive. And I'll talk about that also as we go on. Now, this is another important thing. India's electricity production is dominated by coal. 73% of electricity comes from coal. And therefore, if you look at these numbers, I don't know whether you can see it from the distance, but India is 0.27 kilogram per kilowatt hour in terms of carbon intensity. We are the highest. China is nearly close to us. Most of the other countries have reduced coal. We are still coal dominated. We cannot afford that. We have to move away from that. And carbon dioxide emission from India, this is a slightly old number, 2019. It is that power is due to the coal. Iron, steel, and cement is again coal, largely coal. Then it's contributed by industry, so iron, steel, and cement. Of course, transport is fossil fuel, oil, petrol, diesel. And then there are buildings and other energy like agriculture, etc. But mostly it is a coal based, and we need to do away from coal. That's the point that I'm trying to make. Now, and equally important is that we need to move away from fossil fuel. Just imagine, out of the top 100 cities, the biggest 46 cities, biggest polluters are in India. And not just 46, of course, the largest one is China. Number 2, number 3, number 4, number 5, number 6, number 7, 8, 9, 10, all are India. We are making our environment worse and worse and worse, whether we like it or not. In fact, out of the top 20, I think 16 are India as per that one. And this is going to completely hurt us very bad. So we need to both move away from coal and move away from fossil fuel. Now, what should be the strategy? As I pointed out, the top 10% who have surplus money, and therefore they will like to invest wherever there is a return on investment. Return on investment where you can get good returns, good interest rate or what. So, there is enough money. Top 10% has enough money. So, and we can borrow from banks will also give us money. So, there is no shortage of funds. And it is the top 10% that we really have to tap. So, what does R&D and industry have to do? Basically, take the technology to the level that there is a return on investment. And I think that's our challenge, and that's what I will talk about. By the way, 65% of electricity is consumed by commercial sector, industries, and HIG. Very high income group factories. And they pay between 7 to 11 rupees per kilowatt hour. Now, this was the first thing that we decided to implement. Saying, this is 65% electricity. Can we make that green? If we can make that green, this is our commercial buildings, Commercial buildings like shopping centers, big office buildings where IT things goes on and all kinds of things, plus industries, plus high income group residents, all are mostly for the top 10% of the population. So they have surplus money. IIT Madras Research Park, I talked very briefly about IIT Madras Research Park. Is such a R&D commercial complex. It is a 1.2 million square feet, very large complex. Consumes 50 megawatt hour of power per day. 50 megawatt hour energy per day, not power. And it costs us average 9 rupees 15 paise, including the cost of diesel. Whenever power goes up, we have to use diesel. We said, can we do something there as a pilot? So we said that if I do solar and wind, rooftop I can only get about 10%, 5 megawatt. But there is a mechanism by which I can set up solar and wind plants anywhere, preferably in Tamil Nadu. So we are setting up solar and wind plant as far away as 600 kilometers from Maharashtra. We are setting up that as a group captive mode and wheeling in the energy. So that's what we are doing. So we can wheel in through our existing transmission lines. The problem is we are very wheeling all the solar. Whenever there is a solar and wind, I have to consume it. Because solar and wind otherwise has to be stored. So therefore, a very, very important component that we have to do is local storage. So that whenever solar and wind is available, I use it, whatever I can use. Whatever excess is there, I store it. And when there is not enough solar and wind available, I use from the storage to use. We did a complete exercise. And we see at today's cost, we can bring it down to 8 rupees. Now, from 9 rupees 15 to 8 rupees, I remember we are doing 50 megawatt hour per day. You can calculate 50,000 into that is the amount of savings we do per day. So I went to this plan to my board. Board said it makes obvious sense. In a year, we will earn crores of rupees extra. We'll save crores of rupees. So if this can be done, and can be done at IIT Madras, it can be done anywhere. It can be done for all the buildings of IIT Bombay. It can be done for all the buildings of IIT Madras. It can be done for every commercial complex. And over time, we can make the cost constrained. This is today's cost. It would be today's cost. I can very easily bring it to 7 rupees per kilowatt hour in what today's time. Little more R&D and innovations. So commercial, industrial, and HIG consume 65%. Can we quickly move all of that to green and solar? So that's the first step. We actually said this. We set the whole thing as a pilot, do the thing, and then pretty much set some company to replicate this. Now, the biggest problem is how do I calculate the cost of the storage? And very often, it's batch. Basically, what you can think of as a batch. There are other methods of storage. How do you calculate the cost? Because it's a one-time cost. All of us purchase storage batches from the UPS. Have we calculated the cost per kilowatt hour? And what is the method to do that? Now, this is an important small exercise that every student must learn. And it's a capital cost. I have to buy the battery. But battery does not last forever. It's going to have a limited time. How many times can you charge this charge? So, how many times it can be used? Number of charges cycle. And how many times will you charge this charge per day? That's important. When you say, how does it matter? Well, when you see the cost, you will find that it's important. How many cycles of battery are used per day? And usage cost per cycle. And depends on the mix of renewable energy. If I'm using only solar, in daytime it will charge, evening it will use. But if I use solar and wind, I can charge for some time, then I can use it, again I can charge, and then again I can use it. And if I do more than once a day, it helps. Then is there a leakage? If I keep it, is there going to be a leakage? We need to compute the cost of leakage. We need to do end-to-end energy efficiency. And using all this, we can calculate what's called effective cost per kilowatt hour of usage. If I use the battery for 1 kilowatt hour, how much will the cost be, and add to the cost of generation. And I have to use what's called depreciation and interest cost. It's actually not more than 2-3 classes for us to do this. And simple economics like this, we must understand. We of course also have to worry about, is there an environmental cost? Is there a toxicity cost because of batteries? Is there going to be hazards? Is there going to be recyclability? All these are important, and I'm not going to talk today about it. So, how does one calculate? This is a very simple thing. Effective cost, interest rate, and depreciation computation. You can do what is called this simple formula. It's like if you buy a house and if you have to give a mortgage every day, calculate mortgage rate. It's the very same kind of computation. Capital cost divided by interest rate, number of unit time. Actually, you can do this. You can also do it using a simple Excel sheet. There is a formula called PMP which can actually do this. Now, students must learn to use that because then they will understand if they are coming out with a new battery, what is the potential of that. I'm not going to get into this. But I have taken 2 batteries here. Just for example, the 2 cells that I took, one was the advanced NMC cells, which cost about 20,000 rupees per kilowatt hour is the battery they're using that today. And it can do 7,000 cycles. This is a very high, but available today, high quality NMC cell. I'm calling it advanced NMC. There's also a LDO cell, lithium tantalate cell. It costs 40,000 rupees. And number of cycles you can do is 50,000 cycles, more than double the cycles. Now, what I did is that actually I calculated that if I want to use one cycle, what will be the cost of of storage per kilowatt hour of storage? And you find it very, very interesting. The cost depends a lot on interest rate. First of all, as the interest rate goes from 2% to 10%, the cost keeps on going up. The cost of LDO cells goes up very rapidly. But at low interest rate, it is similar. Now, which are the countries which have low interest rate like 2%, 3%? Europe, Japan, United States. So they obviously can possibly choose LTO or NMC, probably will be same. But when it comes to a country like India, it's a 10%, 12% interest rate. The obvious choice will be advanced NMC. The reason I'm saying is that even in India, when I was in Delhi and doing the work, the advisors will come from the United States, Europe, and they will say LTO is what we should use. And India gladly accepted. I mean, we don't need. I get very upset that our academic resilience dialogue. Even the people academics come from outside, don't even understand. Interest rate in India is not the same as interest rate in the United States, and don't even do a simple calculation. So, but if you look at the cost of storage at 10%, it comes to around 6 rupees, 6 rupees per kilowatt hour. If it's a one cycle. Of course, if you can do 2 cycles per day, the cost comes down. Then it comes to more like 4 rupees. And how it is. If the interest rate goes down, slightly it will help. But this is very critical. Why? Because not only we should choose the right thing, we should look at how can we do 2 cycles per day. Now, if you do understand all of this, then you can actually build a lithium-ion. That was a lithium-ion battery storage, and you can build a lithium-ion battery storage, and the effective cost will come well under 8 rupees per kilowatt hour. But actually, there is another very, very interesting cost, which we often forget, which is more important for a country like ours, less important for Europe, United States, and Japan, and even China, and therefore Korea, and therefore we don't even talk about it. If you look at right now, we won't have this lecture without air conditioning. Because it will be impossible to sit in a room like this. In fact, in most of our cities, most of the time, air conditioning becomes very hard. And particularly in the commercial buildings and industry, all that. They go to the large industry. In fact, in research part, 40% of my electricity usage is air conditioning. Now, if air conditioning is where I'm using most of my energy, can I do something else? And something we build very nicely. What do we do? How do the air conditioning work? We chill water in a basement or somewhere. We chill the water to 60 degrees centigrade. And the chilled water is circulated all throughout. And then you use an air handling unit and then cool the air and then blow the air. So basically, you are chilling the water to 6 degrees centigrade and circulation. A very simple thing that we did. We built a thermal storage tank in our basement for chilled water. Once you build a thermal storage tank, you can actually chill the water anytime, whenever you have surplus energy, and then use it whenever you need. And this is something that we have already done, and the cost comes much less. And this is, we did the first experiment. We can now do much more. So it's a very large tank, but nothing so extraordinary. Tomorrow, I can, if instead of just chilling to 6 degrees, if I could make it into ice, then I get a latent energy. And if I capture latent energy, then my cost will even come down. But bringing the trying to take the water below 0 degrees centigrade actually is highly efficient. But why can't we think of using not water and ice, but other materials which has a temperature at around 10 degrees centigrade, they solidify. Can I think of that? And there's a huge research now going on. So they actually capture in a small volume. I can capture. This is the kind of storage which will make a huge difference. And then we can do similar things for all kinds of ET and all that. We haven't really, basically we are talking about phase changes here. Now, electrical engineering people have to now work with chemistry people and chemical engineering. Let me tell you, this problem will be led by electrical engineering people, but it cannot be solved. None of these problems can be solved by us. Even how to improve the energy efficiency of air conditioning is something that we have to work with mechanical engineers, people who work refrigeration and things like that. Time has come to do more and more interdisciplinary work. And we come to another important thing. Let's look at how in India, how does a solar and wind get generated? And on a typical day, 24 hours, and you find that sun, of course, rises somewhere around 7 a.m., depending on the place per day, goes up by around 1, and then starts falling by 6 p.m. it's gone. So this is pretty much the pattern for solar sun throughout the country. Wind varies. First of all, it is not uniform throughout the year, but it varies. But it can have typical variations. I've done one typical variation, but depending on place to place, it will vary. So short-term energy storage, day-to-day variation. Capturing the energy in the morning, using it in the evening, or using it next day, can be done by two kinds of batteries. One I will call it chilled water storage. Another is lithium-ion battery storage. Lithium-ion comes out to the best cost today. We can look at other batteries as much. I'm not getting into detail. That will be a separate lecture. Why the most cost? I'm looking at the most cost today. New technology will do. But there is a problem. Look at this. This is the India's solar generation and wind generation by months. And in fact, solar generation is more or less constant. Of course, I rainy day, that one day it will dip, next day the sun will come out. Even in the rainy day, the sun will come out for a few hours. So the variation is not that large. Wind, on the other hand, peaks for a few months and then goes down like it. And depending on the region in Gujarat, it is different from Tamil Nadu. That means we need long-term storage, 3 to 4 months storage. I have to capture energy, store it, and use it 4 months of the life. How do I do that? What kind of storage? Can't be anything like that. We can't be storage. And that's the interesting thing that we really have to figure out. And that's again something on which we have to believe. I'll talk about it. Now, let me talk briefly. If you're not just talking for the talk's sake, I hope I'm not crossing the time. Starting a little late.
We started at 5:05, sir.
So what's the time?
5:41.
Another 10 minutes. Look at another aspect. I'm not talking just theory or R&D. I'm talking about how to make changes in the country. Now, to understand, basically, I'm talking about R&D to scale commercialization usage. And I think there is we have to take the technology in 4 stages. The first stage is what is called proving science. Where prove a PCM can capture so much energy and can be kept and used after a few hours. Phase change ratio. That is proving science. Or I have a new solar cells which will give me this. Or I can generate a new turbine which can give me this. So most of us academicians are very good at proving science. Proving science is done largely in lab. And this is the first stage. Identify technology and R&D. And this has to be pretty much funded. It has to be funded either by government or by CSR or by industry. And I will call it a pre-commercial. This has to be funded. But the second stage, this in itself, you can publish paper and that's it. That's important, but that's not the. You want to take to the commercial, and the next stage is pilots. And the pilots I have divided into 2 parts. The first part of pilot is proving technology at scale. So what you have done in the lab is a very small scale. Neither have you worried about the cost, nor have you worried about everything. You have to scale it. You may have done something at 1 kilowatt hour. Now you have to do it 1 gigawatt. 1 gigawatt hour is 1,000,000 times a kilowatt. Or at least 10 megawatt hour. How do you go about doing that? That's a pilot. And you prove that whatever you did here can actually scale. Now, scale is very important because only in scale the cost will come. Then you do scale, cost will not go. So the first is proving technology, and second is proving the economic viability. That what's the cost of doing it? What price can I sell? So this becomes a very important stage. This is where the research part, and last slide I talked briefly about it, comes in. That you take technology from the lab to pilots. Early pilot, proving that technology can scale, still will require a little bit of commercial fund. But once you start looking at economic viability, commercial fund, venture funds will fund. Startups will make a difference. You also will talk about startups. That's where startups really work. And you don't require government fund. In fact, government should not fund. It hurts if government funds. So this becomes a very, very important part. And I think our responsibility is at least till that. The technology viability and economic viability. Once we have proven this, the third stage is what's called early implementation. Early implementation will be still small scale. Because it will be small scale, it will not be economically viable. That will be done by industry. And that's a time that's called build market. That's a time some policy interventions are required. Here, government has to incentivize. I want to subsidize, incentivize, not charge tax, exit tax, all kinds of things. And we again have to ensure that this government is willing to do. And the fourth stage is scale implementation, like we do for solar. Today, no subsidy is required, no support is required. Whatever you do, solar will not cost more than 2 rupees 35 per kilowatt hour at scale, and therefore it will win on its own. We have to then start working the next generation solar because that's what we have to start doing. Now, I think these 4 stages are very important. And this is where the academia often do not fully understand. And our research part primarily is focused on taking technology from here all the way up to here. And this stage is all commercial funds. You don't need government funds. In fact, government funds will come. And this is where you have to work with the industry and things like that. Every technology needs to take. And this is something, otherwise, yes, first stage is important, but not enough. And in India, we are just doing too much of first stage. Now, let me come back to this. So, based on that, I identified what are the technologies we can take it to at least early commercialization, if not full commercialization in 5 years. India can do that. What can we do from 5 to 10 years? And what can we do from 10 to 15 years? I will send you this presentation right to me so that don't have to take a copy of this. See, 0 to 5, solar, wind, and wheeling RE technology exists. Ready. So it's there in 0 here. Grid storage, chilled water, and battery storage. There are already enough pilots have been done. Some pilots have been done. Economic viability is there. We can take it to early pilots, early rollout in about a couple of years. And in 5 years, we can start. This can be done. Energy efficiency in air conditioning and heat pumps. Extremely important. It will require electrical engineers, lot of power electronics. Power electronics will play a major role. I will have to work with the air conditioning people to do this. Not just air conditioning, but heat pumps will play a very important role. Heat pumps is a major, it's the opposite of air conditioning. Every air conditioner is also a heat pump. On one side, it gives you cooling, the other side, it gives you heat. A very important area. Strengthening transmission and distribution for the technology and knowledge exists. We are not focusing on that. I could find academia who understand this area. It's extremely important. I remember 25 years back, 20 years back, 10 years back, when we had to wait for 10 years for Delhi 8 years to Delhi communication was the most important. That time, Hari was the most important person. Today, it is a power electronics which is the most important. And we underemphasize this. We don't understand. We don't realize that. Hydroelectric storage, something that is well known, again, a lot of work. 2 wheelers and 3 wheelers today are economically viable. We are doing a lot of work on something like this. Energy management system, again, something that any one of you can very easily. So, this is the areas which we can do in 0 to 5 years. In 5 to 10 years, we have to crack these problems. Where science has to be done now, pilots and commercialization may be done 5 years, 4th year, 5th year, 6th year, 7th year. For example, long-term storage. The 4-month storage that I talked about, what are the candidates? Not lithium and battery. Things like zinc and that. Things like aluminum and that. What happens? You take zinc, convert it to zinc oxide, zinc powder to zinc oxide oxide. You have captured energy. Convert zinc oxide back to zinc. You have released energy. Do you realize that it's the storage? Again, immense amount of work between chemical engineering, electrical engineering, power electronics people will require. Ocean and wave and tidal energy. I will talk about it. Small waves in India has plenty. Can we really leverage that? Larger EVs and freight transportation. Again, something that we understand quite well. A very, very important role will play a green hydrogen for ammonia. Now, today, ammonia is used for all fertilizers, all our agriculture use fertilizers. And we are buying fossil fuel and doing this. We need green hydrogen from that. The biggest uses of green hydrogen will be that and not electricity. We need to do that. Green hydrogen for cement production. Cement today contributes to 8% of greenhouse gas emission. Immense amount of technology required. First, produce green hydrogen. Then, how do you really produce cement? And there are two parts to cement production. One is from limestone to cement, and another is from cement to concrete. Both gives a lot of greenhouse gas emission. I could talk about it, but I'm not going to talk. Then iron and steel production. Again, today uses all four. Huge problem. Can we really look at green hydrogen from that? Then carbon capture, utilization, and sequestration. Believe it or not, every wall can capture carbon. That's where civil engineering is going to become the most important area in the world, in the country, in India. Because India is going to grow, we are going to grow big. And we never realize that civil engineering is so important. We underplay this. And I think we need the best civil engineers working with all of us, interdisciplinary, chemical, electrical, and every other area, so that we can actually get there. There are other things. Already work is going on. Perovskite, next generation solar. We have got it good, but we are still importing everything from China. Can we get perovskite and can we become leaders in it? Can we do wind turbines, larger capacity, the wind turbines for offshore? That's another area that we need to work. Lot of work. Electrification for construction. Every construction equipment uses diesel and petrol and amount of emissions that input. Every agricultural, can we convert all of that? And all this can be done 0 to 5, 5 to 10. Commercialization. And India can do this, India can lead. We can cooperate with us, but India must lead. Each of these areas, I will give a talk on each of these areas because I've done over the last year and a half enough work on each of these areas, sitting and listening and understanding from a civil engineer or a chemical engineer or some other engineering discipline and figuring out what we should do. All of them have electrical engineering and computer science playing a major role. Without that, none of. But we have to work with others. So we are, for example, already doing solar wind power, wheeling, energy management for green storage, EV subsystem development, motor batteries and chargers. Come to research park and you see this efficient motors and control. All this work we have already started, and I think each IITs and other NITs and others should work, and we will have to work together. But everywhere we will work with them, only the objective is not just to publish paper, but all the information. Then, this long-term stories. We believe that in 12 months we will crack the science. The zinc air with charging discharging. Chilled water storage and hydrates. Hydrates will play a very important role. The PCR, the phase change material, hydrates play a very, very important role. Retrofit chiller and heat pumps at our place. Hot water for showers and kitchens and food storage and cold water for cooling the drink. Today, they are using this for cooling. What happens to the heat? They just dissipate. We have to stop doing that. Hydrogen generation for renewable energy, we are already working on that. And we would like to see what are doing that. Carbon dioxide capture from cement kiln and processing through electrolysis. Decarbonization of cement manufacturing as India's GDP increases to build more. Cement manufacturing today, 35% of carbon dioxide due to fossil fuel used in calcination and 65% during calcination process. Cement plants near limestone locations 6 to 7 inches. Concrete manufacturing closer to construction site, possible to sequester concrete carbon dioxide in concrete block. And carbon dioxide, of course, one problem is if I make pillars, you and put carbon dioxide on it, all the steel will corrode, and that's the strengthening material. So I have to replace our steel strengthening material with glass fiber or with carbon fiber. Again, immense amount of work that needs to be done. So this is all, and concrete wall with space, sequestered carbon can replace steel walls. Of course, we are also raising off topside. Well, last two slides. Where are the bottlenecks going to come from? All this, so far I was talking about R&D and industry. There is going to be huge bottlenecks. What will stand on the way? Do you know that 70% of our 75% of our power today comes from coal plants, and 60% of the coal plants have been set up in the last 10 years. In spite of the fact that we tried to advise not to, but the government is doing all the way. Now, what does it mean? Huge investment has gone on. None of them are operating at more than 50% plant load factor. But that means 50% of the time they are not even operating because there is not enough demand. That means the investment that has gone in is not appreciated, it is not good. They're all using them. And whose money is this? It's banks, State Bank of India money. And where is this? Where does State Bank of India get money from all of us? Our money is sitting in our. If they close down, all the banks and other things will suffer. Large employment will suffer. Similarly, 60% of coal mines, privatized coal mines, happened in 2017. And that is happening in West Bengal, in Chhattisgarh, in Jharkhand, Orissa, Assam, Bihar, which are the relatively low income states, employing a large number of people. What is they close down? And they will have to close down. This will require managed change. Similarly, power discount, every power discount is losing money. They don't want change. Large employment. What about all the auto companies? 8% of our GDP, ancillaries. They don't want change. They are making money in there. And what about all the oil products? All our Maratnas? They don't want oil to go away. This is where the government has to play a very, very important role. They will become a big force against change. And if they may stall change, India will get destroyed, world will get destroyed. We don't have that option, and that's the reason I come to talk. This is the, by the way, the research park. It's 1.2 million square feet. And that's to come visit us. This is a unique place in India. India and the world needs to move towards net zero very rapidly. And the way to do is R&D, very important, something that all of you are involved in. But technology, knowledge, and economic viability, and commercialization. Focus on those who have and can raise capital of money, if there is a return on investment. Our job stops on return on investment. And change management, preserving GDP and economy will be the biggest task that we will have to influence the government and focus on that. Don't start telling us how to produce carbon capture. Don't start trying to say I'll fund this or not fund this. Give us some general funds, we will do the rest. That's good. Thank you. Good. Any questions? Otherwise, I'll go through the first slide. I told you my email ID. If you have a copy, of course, you can take my card. My first slide should have it. My email ID is there. Copy it if you want. Show can tell us.
One question.
Yeah.
So it's not a question. Does your statistics include military systems emissions?
It does. It's a small percentage. In India, it's a small percentage. In the world, it is a little more. The numbers are all used. Yes.
Thank you for your wonderful talk. If you like to visit a city where 100% of the energy is zero,
Write to me.
so it's the next TENSYSMP2022. Canberra TENSYSMP is 100%.
Write to me, and we'll love to understand what you're all the time, one has to learn more and more and more from whoever has done something.
Yes, and when we talk about the future, risk-wise, cells. The future of PV cells you mentioned, risk-wise.
Yes.
Is that also there's a company called Great?
So I'm familiar with what that is going on, and still, before we bring down the cost and compete with crystalline silicon, 23%, we still have some distance.
Yeah. But the question I had was.
But R&D is very important.
Yeah. So the question I had was, what challenges do you see when it comes to sustainability of renewables?
I don't think there is much of a problem. So recycling work has to be done. It can be done fairly easily. Batteries, we are doing it ourselves. We are figuring it out. It's a tough work, but This is 3, 4 years work, 5 years work. And we already cracked by and large the batteries. Even solar cells and every element of wind turbine we can actually do. So less of a problem than handling coal or cement or steel. Those are much more complex. Yes, yes, sir.
Sir, why not nuclear? Like,
Yeah, it was there in my smaller nuclear plant. I don't have enough knowledge on nuclear. Unfortunately, in India, I've been going around trying to talk to them. It's kind of still very close guarded, and it's not open. And I tried to even talk, and then somewhere I got a call from the nuclear establishment. I thought it was a guard porter, was a very good friend of mine, he was former chairman of this place. And he helped me understand it. But even my first step of contacting somebody who tried to work in that area, I got a call from someone that you rescued.
because they feel like we.
I agree, nuclear can play some role. I am not there. I'm not competent with that.
Like,
There are others who are doing it. We need to open up. This cannot be, we are not about small and modular nuclear power plants. This is not nuclear bomb. We need to open it. Yes, any other questions? Arjun, no question? Nobody has any question? Yes?
Sir, at the individual level, at the level of a user, like household person, can you tell me 2 or 3 things that
I mean, you are a researcher, and I will not talk to you as a user. I think focus on R&D to commercialization, on the areas that we can add. There are many more areas. Work with us, you are a researcher, you are a faculty at MIT, right? You don't have a choice but to work on this. You and your students have to work on that. As a user, a lot of things can be done. I know we can talk at a different level. I think for your requirement of your contribution is much more than I do. So I'm not like yes, sir.
Sir, we talk about.
so, can you finish this? Then you give mic. Then you give mic. Just a second.
Yeah, go ahead. So please.
Thank you so much, sir. I have a question. I would like to help startups. So I extensively work with various startups.
Yeah.
I'm well connected in academia, startups, as well as in the VC ecosystem. I would like to help them with tech transfer. So, how is the scenario as far as the tech transfer is concerned?
So we work very extensively. In research park, we have 270 startups. The value of this startup, the public value at which they are raising money is 30,000 crore rupees. This is what has happened in the last 10 years. Every startup is getting into the areas that I'm talking about. Easy. It's now doing extremely well. And yes, if you are ready to work on that, do work with us.
So, as far as the patent number of patents,
I don't think patents are as important. I think this is how patents are overhyped. The value comes from technology. Patent does give protection, so you need, but patents are often overhyped. I think that you know what happened? We professors could write papers quite easily, couldn't do the technology transfer. Then we found that we can do patents more easily, quite easily, and we started emphasizing patents. They play a role, but as far as I'm concerned, they're a little more defensive role. I think we need to really focus on R&D to commercialization.
Thank you. So can you comment on process for generating solar electricity from the solar and using it for producing hydrogen? Then at the low time.
So there are 2 parts that you're talking about. Solar energy today is produced by crystallized air. There are of course different. First, solar has a slightly different technology. So that is very proven. But tomorrow, as it was pointed out, other products can come like skies and things like that. But that work is going on. In fact, IIT Bombay is probably the key place where R&D is very strong in that area. That is producing solar electricity. That's the step number 1. From there to produce green hydrogen, you need electrolyzer technology. And making the electrolyzer technology such that the total cost of producing hydrogen becomes $1 per kg is the aim. Today we are $4 to $4.5 per kg. cage. I think at IIT Madras Research Park, there is work going on. We believe that in the next 3 to 4 years, we'll be able to get to $2 per kilowatt hour. Green hydrogen. Tough, lots of work, lot of different people are working on electrolyzer. Huge. Do you realize that one of the biggest challenge in green hydrogen is power electronics? I don't know whether people understand that. When I delved into it, the biggest challenge is power electronics. That's where the cost reduction will be possible. So yes, lot of work. Green hydrogen is going to play an important role. Green hydrogen, I'm not sure how much role it will play in transport. Very often in India, the government emphasizes the transport. I don't think so. I think it will play as big a role. Maybe not. It doesn't matter. It is going to play an important role in ammonia production, in steel production, hydrogen production, in several areas. Okay? Yes.
So,
Last question.
sir,
Huh? Yes, last question. I know it's getting deep.
yeah, can you give some more examples about some return of investment that have been paid from the sector?
Return on investment basically means that somebody has to make profit. If they make profit, any investor will get returns.
Can you give some examples?
Today's solar, any company, its value is increasing.